the meeting, and here we go. So what are we going to be doing today? So as usual, I'm going to be telling you what we're going to be doing today. So we're going to know and understand. First is the last kinematic equation and the derivation. So only one is left. We did two earlier of distance, time and velocity time. So now if you do of velocity and displacement. The second is solve some examples by using kinematic equation so that we can apply our knowledge. Okay. And the third one is, this is very interesting. One of my favorite topics, Newton's laws of motion. Very interesting, very basic, and very important because these are the foundation of physics. And I hope you must have, you know, heard about them because a very famous formula is based on one of these laws, which is F is equal to ma. I think you must have heard this. And the second is the Newton's third law of motion is extremely famous. Like it's like one of the most famous laws in the world. Every action has an equal and opposite reaction. So I hope you have heard about it because today we're going to be understanding what they really are, okay, from a scientific point of view. Cool. So these are the three kinematic equations we did. Only two we did actually. The first one, V is equal to U plus AT, which gives a relationship between the velocity and time of an object. We did it earlier, the derivation also. And the second also, S is equal to ut plus 1 half at square. Okay. So this gives a relationship between displacement, which is S, and time, which is t. And if you can read over here, wait a minute, I'll start my laser pointer. Yeah, great. So suppose an object is in motion. So we are assuming that an object is in motion and initial velocity is u, okay, starting velocity. It attains a final velocity v in time t due to acceleration a, its displacement is s. So these are the parameters which we look at, okay. And this is the formula we get. So v is equal to u plus at. V is the final velocity, u is the initial velocity, plus at, a is the acceleration, and t is time. Okay. So you can just look over here and understand what these symbols or letters mean. Same is with this second one, displacement and time. Third one. So people, we have not done the third one, which is also important, which is gives us a relationship between velocity and displacement. So if you look carefully on these two formulae, the factor t is present, so time is present. Okay, but if you look at the third one over here, there is no t. So even if you don't have the time of the object, how much time is it taking, you can still understand how fast is it going and where is it going. Okay, like how much displacement, how much distance it has covered. All right. So this is what we're going to be starting with today, and I'm going to show you the derivation. First, I'll stop my video because what happens is that the video panel, like you can't see it, but I can see it. The video panel blocks the screen, so only half the screen is visible. So just a minute, I'll just stop my video. Okay, great. So we are going to be doing with starting with this. All right. So I request you to have a notebook and a pen because this is going to be a little tedious job. It's going to take a little time, and it can get.
Yes,
Thank you. It can get a little boring, but cool. Just bear with me. All right. So first and foremost, are assumptions. So this is in physics. We start with something known as assumptions. Okay. So suppose an object is in motion along a straight line with initial velocity u. So basically, what it is saying is, I have a straight line like this, and I have an object. Let's say I have a ball like this. The ball is going like in the right direction. Okay, and initially it was at rest. When I say at rest, it means that it was the initial velocity, which is u, is equal to 0. Why? Because it is at rest. Okay, so 0 meters per second. So I have a ball. This is a ball. Okay, just assume that this is a ball, and it is kept on a table. Let's say this horizontal line is a table, and I give it a push. Okay, so I give it a push from here, and it starts rolling. Okay, it starts rolling on the table. So now, if you look over here, it attains a final velocity v in time t due to acceleration a, its displacement is s. So basically, our ball, it went over here. Okay, like this, and it took some time t to reach this destination over here. Okay, and the displacement is the distance it has covered from point 1. So let's say this is point 1, this is point 2. So from point 1 to point 2, it has covered a distance s, displacement is. So it is in a straight line. So distance and displacement will be the same right now. It has taken time t and the increase in speed. So basically initial speed was 0 meters per second and final speed, let's say final speed was something, I'm going to write it over here. Let's say it attained the speed of 10 meters per second. So that is the final speed and the acceleration will be a is equal to v minus u by t. Okay. So let's say if it took 1 second to reach there, so it is 10 meters per second square acceleration. Okay. So this is our initial assumption. And from there, we're going to be deriving this formula. And now you may be asking, Bhaiya, kyun derive karna hai? Because it is very important to understand how a formula is created. If you understand how a formula is created, you can create your own formulas in the future if you are interested. If you want to become a mathematician or a scientist, this is very important. So okay, after that, the relation. So this is the relation we are going to be getting. Okay, and this is where we are going to be starting from. And let's say figure number one. I'm going to write it over here. Figure one. Gauri, please, please, please do not annotate on the screen. So just a minute. All right. Come on, man. Who's this annotating, please? So, all right. So this is a figure over here. If you focus on the figure, this is a graph of time versus velocity. So time is on the x-axis, velocity is on the y-axis, and our ball, it started from some velocity over here, u. So this will be, let's say it is, or it started from u, and in time t it reached this velocity over here. Okay, and then what I did was I just drew a dotted line to intercept it on the y-axis over here. This is the dotted line. Okay, and the same thing, this original line over here, this is the position of our ball, and the same thing over here, I have created intercept on the y-axis. I created a dotted line from here and went till here, and just so that it can be geometrically correct, means easier to understand. And to create a rectangle, what I did was I also drew a line like this. Okay, so basically I have a quadrilateral or something over here. And why did I do this is, it is completely unnecessary, but we have to prove this over here. So by using geometry, we're going to be proving. So basically we just drew this in a geometrical way. And then we named it. We named our points C, D, A, B, and O, A, O, E over here, and velocity is over here. So cool. Let's start now. Look over here. The first point, we can determine the distance covered by the object in time t from the area of quadrangle DOEB. So people, what a whenever you have a graph of velocity or even speed versus time, where time is on the x-axis and speed is on the y-axis, speed or velocity. Okay, whatever area you will be covering in the graph, okay, this area over here, this area will be the displacement. Okay, and why is it so is, I'm not going to tell you, just think about it. And once you get the answer, you will be acha kitna, like this is very easy, very obvious. So this is the displacement, the area covered in a speed versus time graph or a velocity versus time graph is always displacement. So over here, our area is something like this. This is the area. Okay. And like this entire thing is the area. I'm not gonna, fill the color. It's gonna take a lot of time, but this is the area basically. And the area is nothing but a displacement. So always remember, in a velocity time graph, the area covered is nothing but a displacement, S. So we denote displacement by S. Okay. So basically right now we have DOEB, which is a trapezium. So let's see if DOEB is a trapezium. So point D is this, point O is this, point E is this, and point B is this. So if I join these points. So yeah, obviously it is a trapezium. You can see. So can anyone tell me what a trapezium is? If you have learned it, I know in your last year. So what is a trapezium? Does anyone know? Like rectangle, triangle and things. Okay, Prathamesh raised his hand. So yeah, Prathamesh, go ahead.
Can I tell?
Yeah. Who's that? Prathamesh, go ahead.
Uh, Highest. A trapezium is a quadrilateral which has a pair of lines parallel.
Absolutely. So if you look over here, this line over here and this line over here, they are parallel to each other, and we have just connected these 4 points, so we get a quadrilateral. Okay, so this is a trapezium. I'm just gonna quickly erase this. Yeah. So this is a trapezium we got. Now, if you go ahead, okay, okay. Yeah. So now we'll go ahead. Okay, so DOAB is a trapezium. We are over here. S is equal to area of trapezium DOAB. So what is S is nothing but, I'll change the color so that you can understand. S is this, all of this. Okay, the entire area of the trapezium is displacement. Okay, so this is displacement. Yes. Now, if I go ahead, the third line, sorry. So the third line over here, S is equal to half into sum of lengths of parallel side into distance between parallel side. So this is nothing but people the formula for the area of trapezium. Okay, area under in the trapezium. So for rectangle, we have breadth into height. For triangle, we have half into base into height. Same thing for trapezium, it is half into sum of lengths of parallel side into distance between parallel sides. So what is sum of lengths of parallel side? So if you look over here, sum of length is nothing but OD. So where is OD? So this is our OD over here like this, and BE. So this is BE. So these are the sum. This is these are the parallel sides, and the sum means addition into, so multiplied by OE, so distance between parallel sides. So what is the distance between them? So the distance between them is obviously this, between these two parallel sides, which is OE. So I multiplied it by OE. Okay, but so if you look over here, but OD means this value over here is equal to U, which is the initial velocity. Why? Because I already have written it over here. Okay, starting me. And BE is equal to V. Why is it like this? Because if you look over here, look at this dotted line, you will see that this is V. Okay, and OE is equal to T. So O is nothing but the on the x-axis over here. So this is time T. Okay, T. So what I did was I just substituted these lengths and these names over here, niche, and I got something like S is equal to half into U plus into T. Okay, so this is a basic formula which I got. And then A is equal to V minus U by T. Now, why is this? Is because acceleration. So this is the formula for acceleration, is nothing but V minus U, final velocity minus initial velocity by time. So I did nothing but I cross multiplied, not cross multiplied. I just put A over here and I just shifted T over here. Okay. And I got this step niche. So T is equal to V minus U by A. I just transferred A and T. Now I took this T. Okay. So I'll just change the color quickly. I'll just erase this. There's a lot of annotation. Yeah. So I'll just take this T and put it over here. Okay. And then I get something like this, which looks like this. S is equal to half into U plus V into V minus U by A. Okay. Now I just perform basic mathematics either ka 2. Like so this 2 I put it over here. Then this A also I put it over here. Okay. And what I get is 2AS is equal to V plus U, V minus U is equal to B square minus U square. So this is an identity I hope all of you know. A square minus B square is equal to A minus B into A plus B. So this is an identity that most of you must have learned. And then what I do is basic nothing but I just multiply, divide, and I get V square is equal to U square plus 2S. How did I get this? Is you just restructure it. So you just put minus U square on the other side. All right. So by doing all of this, I get our final formula, which is v square is equal to u square plus 2as. Okay. So if you are ever asked a derivation in your exam, first of all, the first thing to do is have your assumptions. So these are the assumptions ready. Okay. And then draw the figure, which is also very important. And once you have done this, then just look at the figure over here and then do the steps like this. Okay. So Suraj, you have raised your hand.
हाँ हाँ भैया वो इधर से एक्सप्लेन करना, 1 मिनट में मार्क करता इधर.
English, Suraj, please. Or someone else also raised their hand.
Bhaiya, can you explain the third last part?
हाँ हाँ वही.
All right, cool. Third last means from here.
Yes.
All right,
Yes.
cool. And also Aditya, you also raised your hand. You have the same query or what? All right, cool. So I'll explain it from here. So people, we have okay. So we have this formula over here. S is equal into u plus v into t. Okay. And now this formula A is equal to v minus u by t is the basic acceleration ka formula. Okay. Now I have these two formulas and I'm just going to add these formulas into each other. So what that means is if I have A is equal to, just a minute, A is equal to v minus u by t. Okay. So you just take t over here and you transfer A over here. Okay. So you get t is equal to v minus u by A. Okay. So this is this step. We reach this step over here. After doing this, I substituted the t over here in this formula with this. Okay. And then the next step is nothing but if you substitute this t is equal to v minus u by a over here, you get this formula. S is equal to half into u plus v into v minus u by a. Okay. Just substitute t over here. So this is nothing but if you cancel this, you can also write t over here. Okay. And then nothing.
Oh.
And then you have s is equal to, just a minute. Okay. So if you have s is equal to, so I put, oh God, just a minute. Yeah. So I have this step. So I'll write this step over here. S is equal to 1 half into u plus v into v minus u by a. Okay. So you just put 2 either or a b either leke jao aise. So you get 2as is equal to u plus v into v minus u. Now there is this identity a square minus b square is equal to a plus b into a minus b. So I use that identity to get 2as is equal to u square, sorry, v square minus u square because there a just a minute. Yeah. So is equal to v square minus u square and nothing. I just put u over here. So what I got was v square is equal to u square plus 2as. So this is how I got the formula. Okay. Great. So Aditya, you're raising a hand. Any question?
Yes,
Go ahead.
I have a question.
Just go ahead.
Bhaiya, like uh, if we take v square on the opposite of equal side, like from right hand side to left hand side, it will be minus v square. 2as will also be minus 2as, and u square is also minus u square. So how is like here if the number is positive?
Okay. So to answer your question, what you're saying is basically we have 2as is equal to v square minus u square. Okay. So if I take v over here, so I get minus v square plus 2s, right? So let's say I take 2s over here. Okay. So I get something known as minus u square minus 2s. Okay. Are you there with me till this step? So what will happen if I
Yes.
multiply the entire equation by -1? What is going to happen? We have -4.
Plus.
Exactly. So it's going to be converted into this thing. So if there are negative signs on the same sides, okay. If there are negative sides on both sides of the equation, they can be transferred into a positive thing, okay, positive sign. So we
Okay.
have minus over here, and minus over here. That's why. पर ये अगर प्लस होता तो हम लोग ऐसे नहीं कर पाते. Okay.
Yes.
So this is people. This is the basic derivation. Someone just take a quick screenshot, put it on the group, and put it done in the chat box so that I can know, and then we can go. I'm gonna wait for 5 seconds. So 5, 4. Oh, great! Already done. Thank you, Aditya. So this was the last derivation. Now we're gonna have two questions, just two, and you're gonna help me solve it. There is a big hint. Like there's only hint is that you only have to use the kinematical equation. Okay, to solve these two questions on kinematic equation because it's literally given over here. So the first question, I'm gonna request Piyusha if you can come off mute and quickly read the first question for us.
Yes, we have. An aeroplane tax, taxis on the
Taxi.
runway. Taxis on the runway for 30 seconds with an acceleration of 3.2 meter per second square before taking off. How much distance would it have covered on the runway?
Okay, thank you. So people, taxis means so basically if my aeroplane on in an airport, okay, if my aeroplane is in an airport and I have to take it from parking, it is parked somewhere, take it from parking and I have to fly it. So what the word of doing that is taking the aeroplane from the parking or from the hangar to the runway is known as taxiing. So taxiing means nothing but driving the aeroplane. Okay, not flying, driving. रोड पे उसको रनवे पे लेके जाते हैं तो that process is known as taxiing. Okay, for 30 seconds with an acceleration of 3.2 meters per second square. So this is square, but it's not shown right now. All right. So great. How much distance would it have covered? So people, the first step always is write the given so that you know what parameters you are working with. So let's see what is the given over here. A is equal to 3.2 meters per second square. It is already given. T is equal to 30 seconds, which is given. U is equal to 0. Why is it U 0? Is because the aeroplane started from parking. Okay, the aeroplane was parked. And S, now we have to find the displacement, which is S. So tell me which formula will I use? Anyone? Which formula will I use for this? Look at the parameters which you have and what you have to find.
Bhaiya, can we use velocity?
So which like 1, 2, first, second, third, which equation will I use?
Yeah, we can use the second one.
The second one, yeah, correct. So S is equal to ut plus 1 half at t square. Why? Because we have u, we have t, we have a. We just have to find S. So sirf you have to just put the values in the formula. So S is equal to ut plus 1. It should be 1 half. Okay, so 1 half at t square. Oh god. So 0 into 2. All right. So tell me if this answer is correct or not. Like, oh crap. And then 96 meters. Okay. Wait a minute. I'm gonna solve this for you now over here. Let's say. So we have S is equal to ut plus 0.5 matlab half at square. Okay. What is A is at square. Okay, great. So if S is equal to U is 0, so 0 into 30 is nothing but 0. So this is gone. Plus half into A is what? 3.2 meters per second square. Into 30 square is nothing but 900. So if you cut this, we get 450 and you divide this. So 32 into 45, anyone knows 32 into 45? If you, that's 90. So 990 or something, 99 or something answer. Anyone quickly just take a calculator and calculate this. 45 into 32. Wait, and I will only do it. Just a moment. Oh, 1440. Yeah, it's correct.
Bhaiya, answer is correct.
Yeah. Good. I thought it was wrong, but it's correct. So that's great. We just cross-checked it. That's nice. After that, the second question, Isha, can you just quickly come off mute and read the second question for us?
A kangaroo can jump 2.5 meter
Vertically.
vertically. What must be the internal velocity of the kangaroo?
Yeah. So what is,
Given
yeah.
A is equals to 9.8
Meters per second square.
meter per second square. Uh, Speed is equals to 2.5 meter. Velocity is equals to 0. You must be found.
Yeah, exactly. So people now, kangaroo can jump 2.5 meters vertically. So this is something we know. Okay. And now A is equal to 9.8 meters per second square. So can anyone tell me why is it like this? Why have I taken A as 9.8 meters per second square? If you have learnt about this or heard about this anywhere in your life. And it's a wonderful concept, to be honest. So this is nothing but it is known as acceleration due to gravity. So what is acceleration due to gravity is everybody knows what gravity is, right? It is a force that pulls an object towards itself. Okay, that is gravity. So what is acceleration due to gravity is nothing but the gravity is a force which is acting on it. So you're living on Earth on its surface. Because of gravity, you don't fly off, okay, in space. But if you were on the moon, gravity is 1/6 of Earth. So basically, you just bounce on moon. Okay. On Earth, the gravity is what? Perfect. So that's why we live over here. We can keep our legs on the ground. So basically, what acceleration due to gravity means is if I jump from a building, okay, what will be the acceleration? Like how fast will my speed increase of falling due to gravity, due to the application of gravity? Okay, so that is acceleration due to gravity. And many fast scientists all over the world, they worked on this problem. They asked themselves, what will be the acceleration due to gravity of people living on Earth? So they came to a conclusion that it is 9.8 meters per second square. Okay, so this is a very precise value because like the scientists have calculated it. Okay, so that is why this is known as acceleration due to gravity, and it is 9.8 meters per second square. And if you're interested in knowing about this more, you can always search about acceleration due to gravity. Pretty interesting topic because we live in India and we are closer to the equator. So for us, the acceleration will be greater compared to someone who's living in Russia. Okay. And also there's a very interesting reason for this. But anyway, we'll go ahead. S is equal to 2.5 meters. Why? Because it is given over here. Final velocity is 0. So people, can anyone tell me why the final velocity now is 0, not the initial velocity? Anyone?
Bhaiya, I think because it has landed.
Yes, it don't have any movement. It's on a place.
Yeah. So people, I'll tell you, if most of you must have played cricket, right? So if you would have hit a ball or thrown a ball towards your friend, the ball it goes to a certain distance, highest distance, okay, and then it falls down. So that at that highest distance, the speed of the ball is always 0. Okay, and the reason is that the gravity is acting on it. Okay, so you throw the ball upwards towards your friend or whatever. You throw the ball upwards, gravity is continuously acting on it, and because of that what happens is that your force and gravity at one point of time are equal. So the ball becomes zero, and then your force becomes lesser than gravity's. So gravity pulls it down again. So that is why if you are playing cricket, the ball comes down after you hit it. Okay. So that is why velocity will be zero. So I'll just annotate it on the screen. You are over here as a person, and you throw a ball. So this is a ball. Oh god, this is a ball. Okay. You throw it like this. The ball reaches this point, and then it falls down. Okay. At this topmost point, the velocity will be zero. Why it will be zero is because you, as a person over here, threw the ball with a force F in the upward direction. So force is acting in the upward direction, but at the same time, gravity, because of Earth, gravity acts in the downward direction always. That you know, okay. So it went till here. At this point, the force you have acted on is equal to the force acted by gravity, and denote that this is in opposite direction. Okay. When it was going up, your force was greater than gravity's force, and now when it's coming down, gravity is greater than your force. That is why it goes down like this. So at this point, the velocity will always be zero, and that is why we say v is equal to zero. Okay. So great. We'll go ahead. So this is how I solve it now. So this is how we solve it. So what I did was I used the third kinematical equation, v square is equal to u square plus 2s, because we don't have to find out the time, and we don't have the time right now in this problem. So I use the third equation. So in this step, I just substituted our values. So v square matlab 0 is equal to u square plus 2 into minus 9.8 and 2.5. Okay, now this is also very interesting. Why is the negative sign used over here? Why not positive? इधर लिखा है. So people, the thing is that when you jump from Earth's ground, so basically, let's say ऐसा ground है, okay, and you are over here. If you jump upwards, it is going against gravity. Gravity always acts in the downward direction. So if you jump upwards, then the acceleration will be opposite to gravity. So I say minus 9.8 to show the direction. Remember, people, acceleration or velocity, they are vector quantities. And if I'm on a building like this and I jump, okay, from a height, I jump niche aise. Now my acceleration will be positive. Why? Because it is in the same direction as that of gravity. Okay. So using the same example over here, my acceleration is minus 9.8. Also, I've given you the explanation over here. Negative sign is used as acceleration is opposite direction of velocity. And then you do nothing but you solve this. You multiply 9.8 and 2.5. You get u square is equal to 0 is equal to u square minus 49. You put 49 over here. You get u square is equal to 49. The root of 49 is nothing but 7 meters per second. So you get the answer u is equal to 7 meters per second. Okay. So if you have understood this, give me a yes in the chat box so that I can go ahead. Great. Someone just take a screenshot and put it on the group so that we can go to the last part of our lecture today. This is the most interesting and most lovely part, which I love a lot. So yeah. Great. I can see yes. Okay. So now we go to the last part, which is okay. Now basically last. So okay, I forgot there was a check over here. So what are the three kinematical equations? So people, there are three kinematical equations. You all know, right? So they are relationships between different things. So can one by one, can you come off with and tell me what the relationships are? So I'll tell you the first one. The first one is v is equal to u plus at, which is a relationship between velocity and time. So can someone tell me what is the second kinematical equation about? Quickly just come off with and tell me.
Bhaiya,
Yeah.
S is equal to ut plus 1 upon 2 80 square.
Yep, thank you so much. And what is it like? What's the relationship between now in this? S is equal to ut plus 1 half 80 square.
But there is the relationship between displacement and time.
Absolutely, thank you so much. So yes, so as so basically it is a relationship between displacement and time. So now people, the third one, the third last one.
Can I, bhaiya?
Yeah,
Can
go
I?
ahead. Okay, first कौन था? Okay,
Uh,
yeah, Radha, go ahead.
B square is equal to U square plus 2AS.
And what is the relationship between?
It's about
Velocity and
displacement.
displacement.
Yes.
Absolutely, whoever said that, awesome. So velocity and displacement. So these are the three kinematic equation always in your life. Remember these, okay? Always, because they're very important. Basics of physics here. And yeah, Suraj, there is no time in third. This is also a great observation. So these are the three kinematic equation. And now go ahead to Newton's laws of motion. Abhi, traditional physics का foundation है ये. Three laws of motion, which were done like 350 years ago by a very, 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 very smart person who was Isaac Newton. And वो apple उसके हाथ में गिर रहा है वो. So it's a very famous story that Isaac Newton, how he discovered gravity was, he was sitting under an apple tree. Okay, Aditya, raising your hand. You know the story, or if you want to
Yes.
Yes, bhaiya.
go ahead.
Bhaiya, it is said that apple didn't actually fall in its head. It was just that he was observing that apples are falling from the tree and are coming down only. This made him thought that there is one force that is pulling the apple only downwards only. So that's how he discovered gravity.
Absolutely, absolutely. Yes. Radha, you're raising your hand. You have,
Yes.
yeah.
Yes. Yes, bhaiya. And he also thought that why is it not flying over or going ahead or sideways?
Absolutely, yes. Thank you, both of you. So yeah, Newton was, chilling under a tree, and then, or basically, let's say like there was a tree, there was an apple, and it fell down. Newton was there, or wherever he was, under, over, near, far, he saw it, and he questioned to himself that, wait a minute, why is that apple, falling down? Why isn't it flying off? Okay, क्योंकि as force works, for an object to move, you need some force on it. So he began thinking, wait a minute. So that means there is a force acting on that apple which is in the downward direction, and that's how he found out about gravity. And because of that, the modern foundation of physics was set. So these are the three laws of motion, and one by one we are going to be seeing what those laws are. But before we do, people, I'm going to show you a video, okay? So basically, me telling you, like better than that, there are various videos on this because this is a very basic topic. So we'll just look at those videos.
Give the example of the car. When we stop, we feel a sudden motion, and that's inertia.
Absolutely. So inertia, people, is that all objects like us humans are lazy. सब आलसी होते हैं. They don't do anything on their own unless and until a force acts on it. So that act of not doing anything is nothing but inertia. We say that the body has inertia to it. It continues to be in the same state it was. So that state is known as inertia. Okay, great. So I'm going to go to the second slide now. This is known as second law of motion. So before we go, as always, I'm going to show you this video so that things are a little more clear. Okay. So now the same thing, if you can see and hear my screen, give me a thumbs up. Abhi start nahi kiya hai, ruko. Okay. Give me a thumbs up.
Do you remember the Newton's first law of motion? It says that an object will continue to do what it's doing unless acted upon by an unbalanced force or some net force. Now the important question is, what happens when there is net force acting on an object? That's precisely what the second law of motion will discuss. Do you remember understanding the first law of motion with a simple diagram? If the forces are balanced, the acceleration will be zero. In the first case, the object will continue to remain at rest, and in the second, the object will continue to stay in motion at the same velocity and in the same direction. Don't forget, these two cases will remain true only if the forces are balanced, only if the net force is zero. Now let's try to create a similar diagram for the second case. If the forces are unbalanced, then there will be acceleration. We saw that in the previous video. And now we come to the interesting part. Let me ask you a question and I'm sure you can answer it. On which two factors do you think the acceleration will depend on? I want you to tax your brain a bit. Let me repeat my question. On which two factors do you think will the acceleration depend on? Okay, let's say there's an object on a table. You apply a net force of 10 units on it. And then you apply a net force of 20 units on it. In which case do you think the acceleration will be more? Of course, the one in which the force was more. So we can say that one of the things the acceleration depends on is net force. If it's more, then more will be the acceleration. If it's less, then lesser will be the acceleration. Acceleration depends directly on the net force. Come on, now I want you to think about the second quantity the acceleration will depend on. Let's say there are two objects on the table. One has a mass of 3 kilograms and the other has a mass of 5 kilograms. Now, if you apply net force of 10 units to each of them, which one do you think will accelerate more? Surely it's the 3 kg one because it has lesser mass. Lesser the mass, more the acceleration. And more the mass, lesser the acceleration. Hence, we can say that acceleration depends inversely on the object's mass. If you understand this concept well, then understanding the second law of motion will be very easy. Mathematically, it can be written like this. In simple terms, the acceleration is directly proportional to the net force applied and inversely proportional to the mass of the object. That's the second law. Or as more people understand it, like this. The net force is the product of mass and acceleration. With this, can you tell me the units of force? That should be easy. The standard unit of mass is kilograms, and that of acceleration is meters per second squared. So the unit of force is kilograms times meters per second squared. And this is what we call as Newton. 1 Newton is 1 kilogram times meters per second squared. So if the mass of the object is 10 kilograms and the acceleration is 10 meters per second squared, then the force will equal 100 newtons. We can say that 1 Newton is defined as the amount of force required to give a 1 kilogram mass and acceleration of 1 meter per second squared.
Okay, so people, what do you understand by this? Okay, I can see that some of you have understood this concept, and yeah, and it will be great. Okay, so basically, second law of motion is nothing but let's say just yeah. So there's one more concept. The video didn't tell us is known as momentum. Okay, momentum. So momentum is nothing but the product of mass of an object into its speed or velocity. So momentum is nothing but mass into velocity. Okay, this is momentum, and we denote momentum by n. Yeah. So the initial momentum object is mu, final momentum is mv. Rate of change of momentum, rate, people, rate is here. Rate means per time, is mass into f is equal to ma. Okay. So the video said that acceleration depends on two factors, which is nothing but force and mass. Mass means the how much it weighs basically. So imagine if the object is heavy, then the acceleration will be slower. Okay. And if the force is greater, then the acceleration will be greater. So basically it looks something like this. This is known as proportionality sign. Okay. So basically A is equal to F by M, which is F is equal to MA. Okay. And this is the technical, very formal definition of what second law of motion is. And it is nothing but rate of change of momentum is proportional to applied force, and a change of momentum occurs in the direction of force. So this is a very technical term. Okay. So if you understood the second law of motion, give me a yes in the chat box so that I can know that. Acha, samajh aaya, bachcho ko. If not, then wait after the lecture. I'll tell you after the lecture. Okay. Great. So people, we come to the last part of our lecture today, which is third law of motion. Now, this is one of the most famous laws in the world, and I am sure you must have heard about this, is that the third law of motion is nothing but for every action, there is an equal and opposite reaction. Okay, so this is the most famous law in physics world. And before we go, we'll just quickly watch the video. Okay, and then we can go ahead. So this is the last video I'm going to be showing you for today. Just a minute. I'll share my screen. Again, if you can see and hear the video, give me a thumbs up. Great.
The only question you need to ask yourself while studying the third law is, what happens when two objects interact with each other? What happens when you place an object on the table? The object exerts a force on the table and the subject exerts an upward force on the object. There are two forces that result from this interaction: a force on the table and a force on the object. The magnitudes of the two forces are the same, but the directions are opposite. These forces are called as action and reaction forces. The force exerted by the object on the table was an action force, and the force exerted by the table on the object is the reaction force. What we saw here is nothing but a display of the Newton's third law of motion. Every action has an equal and opposite reaction. That's how simple the third law is. Every action has an equal and opposite reaction. It means that when two objects interact, there is a force on each object. The magnitude of force on the first object equals the magnitude of force on the second one. And what about the direction? The direction of force on the first object is opposite to the direction of force on the second one. Let's talk about more examples. While a frog is swimming, it pushes the water back and the water pushes its body forward. Now let me ask you a question. Say a bird is flying upwards. Will the Newton's third law apply here? Sometimes the third law is not so obvious. You'd probably say that the bird is the only object here and there's no second object. But that's not correct. The wings of the bird push the air downwards and the air pushes the bird upwards. Action and reaction forces make it possible for birds to fly. We take one last example to understand something very interesting about the third law. What happens when a gun is fired? You're right, it exerts a forward force on the bullet, and the bullet exerts an equal and opposite reaction force on the gun. And this exists in recoil of the gun. A perfect example of Newton's third law. But hold on. If the force exerted by the gun on the bullet is the same as the force exerted by the bullet on the gun, then why doesn't the gun recoil with the same acceleration as the bullet? The gun recoils, yes, but it doesn't recoil at the same acceleration as the bullet, right? Same magnitude of forces, but different accelerations. Why do you think this happens? Okay, so if your concept of the second law of motion was clear, you wouldn't really be surprised with this. The second law of motion says that the force is the product of the object's mass and acceleration. Or the acceleration of the object is equal to the force over its mass. What does this tell us? Yes, if the mass is more, then the acceleration will be less. In this example, the mass of the gun is much more than that of the bullet. Hence, the acceleration of the rifle is lesser than that of the bullet. If you're in a boat and step out of it onto the land, there are two forces involved. You pushing the boat behind and the boat pushing you forward. And that's why you see the boat go behind when you go forward. Now let's say a sailor jumps off a huge ship. The sailor does apply a force on the ship, and the ship also applies a force on the sailor. But do you think the ship will accelerate as much as the sailor? Not really. And I think you know why.
So people, here it is the last third law, and for every action there is an equal and opposite reaction. So the same example that we saw in the video, it is in this picture over here, where this guy over here, he is on the edge of the boat and he's going to be walking forward. Okay, so his force, actually his action is in this direction, but the applied force is in this direction. So because of that, um, when the guy goes in this, the boat moves in like the opposite direction. And many times what happens is people, if you look at funny videos on YouTube, the guy falls into the water because of that. Okay. And if you look at the first image over here, same thing. The ball is coming from this direction. So if the exact opposite direction of this ball is in this, okay, and that is the reason why this ball, whenever you play cricket or football or whatever, it goes in the opposite direction. Okay. So this is nothing but the third law of motion. If you have understood this, give me a yes in the chat box. If, if yes, okay, so that I can know that yeah, okay. I can see a couple of yeses in the chat box. So that's wonderful. Thank you, people. So yeah, so with this we come to the end of our lecture today. Don't drop off right now. Wait a minute.